is we're going to take our molar mass, this number that we just got, and here's what we're going to do. If we want to find the percent composition of copper, I'm going to put copper's molar mass or copper's mass on top. What is the mass of copper? So 63 times 0.546. And you always multiply the number that there are, but how many coppers are there? Okay, so that would be like multiplying by 1 over the entire molar mass, which is what? 223.354. And then you always at the end, because this is a percent thing, you multiply by 100 to get us a percent. So 63.546 divided by 223.354 times 100. And did y'all get from that something like 28.45? Yeah? Question? 63.546? Yeah, that's a 4. Oh, that's the mass of copper. I'm focusing right now on copper. And how many coppers are there? 1. So 63.546 times 1 divided by 223.354. The mass of the entire compound. Multiply that by 100, I got 28.45. That must mean that that is the mass of copper. Or the percent, I'm sorry, composition of copper. 28.45%. Cool? On this, you just go to 2 sig figs. Or 2 decimal places, I'm sorry. Do 2 decimal places. Okay, what else do we have to find the percent composition of? Bromine. So let's focus on the bromine real quick. Well, yes, you could do that, but let's show how to actually really work it out. What is the mass of bromine? That always goes on top. 79.904. And how many bromines are there? So that would be times 2 on top. And what always goes on the bottom on these problems? Of the entire compound, which is 223.354. And of course at the end we're going to multiply it all by 100. So I'll let you put that in your calculator real quick. 79.904 times 2 divided by 2223.354, and then multiply that by 100. 71.55%. Now what should my 2% add up to be? 100, because there's only 2, and you could add that up. There, it is 100. Good? So percent composition. You put whatever part you're looking for over the entire thing. Cool? Let's look at this next one together as well. You got sodium, O, and then H. So I'm going to be doing 3 separate problems if we think about it. A problem for O, a problem for H, a problem for Na. And what do I always do first on these percent composition questions? Very good. So why don't you guys go find the molar mass of sodium hydroxide. 0.997.
Yeah.
Cool. Okay, so for my sodium, what am I going to do to solve for the sodium, Na? It's 22.99 times what? Yeah, because there's only one of them. And what do I always put this over? Which is, so 39.997. And then, of course, at the end, I always multiply it by 100. So I'll let you do that real quick. Did y'all get what I got? 57.48%.
Yeah.
Cool. How about for oxygen? 15.999 times 1, because there's only one oxygen, over 39.997. Of course, we always multiply by 100 at the end. I got something like 40.00%. Is that what y'all got? And then lastly for hydrogen, 1.008 times 1, there's only one hydrogen here, that's its mass, over the entire mass, the molar mass of the compound. Multiply that by 100 at the end. Not necessarily, no. And I got 2.52 for my hydrogen. Is that what y'all got? What should all these add up to be? I even checked it myself. They all add up to be 100, so it does work out. Good? Now, I'll lead you into this next problem real quick. How many different atoms or elements do you see here, I should say? How many different elements? So I've got one area for nitrogens, one area for hydrogens, and one area for sulfur, or one area for sulfur. I'll divide them up. How many nitrogens do I have in this compound? 2. You got 2, so that would be 14.007 times 2 for the nitrogens. How many hydrogens do we have?
8.
So that'd be 1.008 times 8 up top for that one. How many sulfurs? So 1 times 32.066 for the sulfurs.